Alright, here's how to design your very own S blade in Onshape. So we'll start off with the Repeat Robotics ant weight hub motor keying design. This profile in the middle is what we'll use to start off. And because it's on the right plane, I'm going to start sketch on the right plane. And you can get this design from GrabCAD. I'll have a link in the description. So starting off, we're going to need to project this inner profile into our sketch. So I'm going to select one of the edges and click tangent connected edges so it selects the whole thing. Then I'll click use, and if we hide the part now, you can see we have the entire profile in our sketch. So first thing I'll do to make the actual blade is make a construction circle. That's the diameter of our blade. Let's say it's 4.5 inches. I have it in millimeters, but if you type in inches, it'll auto convert. So first thing I'll do here is make a vertical construction line. It's going to be for a tooth side weapon, and I'll make leading edge here have a rake angle of, I don't know, 10 degrees. That looks good, and a length of, I don't know, 10 millimeters. We can all change this later. And then you're going to want a circle on the outside. You'll see what we use this for soon. Let's make it 52 millimeters, sure. Then we're going to click arc, make an arc connecting the line, and the circle, we made sure it's tangent to this line, and make it tangent to the circle too, with T. Next thing we're going to want to do is click center point arc, make a center point arc connecting the line with the outer edge. This is going to be the outer edge of our tooth. And then I'm going to hit A again to make an arc, and make one connecting the tooth and the circle, and I'm going to make this tangent too. So it's not very constrained right now, so I'll dimension it to be, I don't know, 9 millimeters, and I'll dimension the arc to be, let's say 90 millimeters. That looks about right. Next thing we're going to want to do is make the counterweight blade profile. You can make a symmetrical blade if you want. If you wanted to do that, you would go here, circular pattern, select this whole thing, and it would make you a circular patterned symmetrical blade. That's a tri-blade. Yeah, so something like this, but I'll show you how to make a asymmetric blade, because a lot of people get stumped on that when they're starting out. So to make the other side, we're going to recreate the same thing. We'll make a construction circle and give it, actually, why don't we dimension it based off the big circle? Let's say it's got dimension of 15 degrees. Nah, maybe 14 or 13. Yeah. And then we'll make another construction line and basically copy what we did by making a line, giving it a rake angle, 10 degrees, sounds good. Giving it a length, 9, and giving it an arc. Connects it to the circle. So we'll make that tangent, and we'll make these tangent too. And now we need to constrain this, so I'll constrain it to the original line we made, and I don't know, 140 degrees seems good. We'll change this later. Then we'll do the same thing we did and use center point arc connected to the counterweight side. That seems good. And then have an arc. And this should be tangent of the circle. So it's obviously too big. Looks kind of strange. I would say you can play with it until it looks good. Something like this where you see the arc kind of mimics the entire thing, so it looks like one smooth profile. Looks good. And I'll dimension this 59, and we'll need to constrain it one last time with one of these construction lines, and I'll base that off of the vertical construction line too. 138. That seems good. So you can see we have a pretty decent S-blade profile. I will say the one thing I'll keep in mind is that usually you want your keying profile, like the screws and like bumps and stuff you see here to line up with your tooth and counterweight. But right now it's completely vertical because of how we made the sketch. So what I'm going to do is I'm going to take my original construction line I made that's lined up with the tooth, delete the vertical constraint, and rotate the entire thing until it looks like this. And what this does is that it lines the hub motor mounting with the blade a lot better. And to constrain it, I'll make another vertical line. This time it's actually going to be vertical, and constrain the top line. 20 degrees sounds good. So now what we can do is finally extrude the actual blade out. Let's say it's an ant weight, make it 1/8 inch, or 3.175 whatever millimeters. And right off the bat we see we need to fillet this. You can do filleting in the sketch, but I wouldn't recommend that for beginners. And for a fillet size, I would say 7 millimeters is good. Honestly, for the counterweight side, I might just make it a bigger fillet, so a separate one of 15, just so it looks smoother. And another thing I would want to do at this point is, if you look at it from the right profile, you can see how near the middle seems a lot more kind of uneven. So if I modify fillet these two edges and actually make the arcs have a greater radius, it kind of thins it down more. So before, you can see the curvature is a little almost poking out there, and afterwards it smooths it out to make it one even profile. So I'm gonna go back and change it to make it a little thinner. I don't think it needs to be this thick. And this will also make it look more smoother. Oh, it looks pretty thin here. So we'll go back and change it. That's the nice thing about CAD, is that you can always change your designs. And I'm going to decrease that angle we did. That looks pretty good. So at this point, we're gonna wanna just make sure that it won't break horribly. In Onshape, you can use the measure tool by clicking two things. And in this case, we want to find the minimum distance between these two features. So the minimum distance is 6.767 millimeters. So that seems fine. The next part is pocketing. Now in Onshape, there's two ways you can pocket. One is the easy way, but you don't get much freedom over pocketing. Two is the manual way. I'll show you how to do the easy way. So first, you're gonna make a line through this. It can be pretty rough, you don't have to constrain it. And in the sketch where you do that, make sure you unclick disable imprinting. Then you're gonna want the feature script, which is like a plugin called Lighten. I think it's an official feature script. If you don't know how to get this, then look it up. So we're gonna click Lighten, and we're gonna click one of them first. And it should be through all. And I think tool radius of 2 should work, and wall thickness of, I don't know, maybe 12. And it's not actually, like, this distance isn't 12, it's actually half of whatever you set the wall thickness to. So this is 6 millimeter wall thickness. So we'll do the same thing for the counterweight side. I'm going to change it to maybe higher tool radius, because it's a little funny if you have it too small there. It's kind of a little obvious that you used a feature script to do this. I think 3 looks about right, and we'll call that done. We'll hide the line, and here is a pretty decent blade, I would say. One thing that looks a little unnatural is this bump artifact it's actually from these two screw holes in the profile. So what the feature script did is that it's curved this out and offsetted it, and it looks a little funny. So what I'm going to do is hit modify fillet on these two and increase the radius so it's less noticeable. And we don't need too much meat here, this distance, so it really doesn't matter too much. Now we have a pocketed AR500, presumably 3mm 4.5-inch ant weight size repeat hub motor S blade. And last thing we need to do, of course, is balance it. So we'll need to assign a material, right click on it, assign material, Onshape materials library. I just do 400 series stainless steel, works well enough for AR. And if we click this button here, we zoom in on the origin. We can see the center of mass is not quite at the origin, it's pretty close. So here you can see it's 0.6 millimeters off in the Y direction and 0.05 in the Z direction. So I'm going to want to increase material over here or decrease the material on this side to get it close enough. I like it at around 0.05 millimeters away from the origin or less. So to balance it, I'm going to probably move these. And a lot of CAD is just messing around and seeing what works. But for now, this is a good stopping place. If you want a quick, easy blade design, then you can just follow this.